Well, thanks everybody for joining us. Part two of heat trace presentations this month. Last week, Charlie did the chroma trace and some of the design parameters to review. This week, we're going to do some troubleshooting, some of your basic troubleshooting, basic product overview, and explain how the customer presentations are going to continue to evolve as we go. With that said, Chad Gautreaux is here, one of our heat trace experts, regional technical sales manager for the East. He's got 40 years experience with power distribution, but over 20 of that with heat trace alone. So certainly one of my mentors. So from there, Chad, it's all yours.
All right. Good afternoon, guys and gals. Thanks for joining. What I'm going to do this afternoon is we're going to do like a brief overview of troubleshooting, heat trace troubleshooting, just from the experience that I've had over the years. And so it'll be a highlight of some things that you can look for, that your customers can look for. And so but what I'll do before that is we'll talk a little bit about the history of Chromalox, which a lot of you guys are pretty well aware of, and a little bit about product, and then we'll jump into the troubleshooting part of that. So as most of you know, Chromalox has been around for over 100 years, which is quite an accomplishment when you stop and think about it. Companies sometimes don't last that long, with our first patent in 1915, and we're still the leader in electric heater products, and still have a big breadth of product and application knowledge. And of course, we're still headquartered in Pittsburgh. The building looks a little different than it did back in 1915, but we're still in the Pittsburgh area. All of our heat tracing manufacturing is out of Laverne, Tennessee, in the 150,000 square foot warehouse. That's where we manufacture all of our cables, panels, our controls. Our application engineering is out of there, design engineering. Of course, we warehouse all of the equipment out of there, and our site services ran out of our Laverne, Tennessee, which is just south, about 15, 20 miles south of Nashville. Like I said, we still have a broad breadth of products, of heat tracing products, our cables, engineering services, components. Of course, we can do tubing bundle enclosures and tubing bundle products, as well as the full breadth of our heat trace controllers, from our single point controllers to our freeze protection panels, our digital thermostat controllers, and our ITLS and ITAS larger panels. And of course, all of those will communicate with our IntelliTrace supervisory software. And we do all of our design out of ChromaTrace, which we saw last week with Charlie's presentation, where we get all of our design for heat tracing. And that's the breadth of our designs and where all of that comes from. Let's talk a little bit about heat tracing. So in my years of heat tracing, I kind of broke heat tracing categories into there's three different main categories: freeze protection, process maintain, and then there's commercial applications. So freeze protection, in my mind, is the prevention of water from freezing in pipes and vessels. And that's typically controlled by an ambient sensing thermostat, and it's a group controlled application. I'm sure many of you are familiar with freeze protection. In the 20 years or so that I was in the business down here in the South, we didn't do a lot of freeze protection because we're just so far south, it's not necessary. They kind of hedge their bet against pipes freezing, but we do get a lot of that in a lot of your guys' territories. And then process maintain is the maintenance of a specific temperature that's based upon process chemical data. And that's typically controlled by a line sensing RTD, and is typically a single controlled circuit application. Now, you will see some people that will still try to do this with a group application. It can be done. It's not recommended because you have different heat losses for different pipes, and some pipes may end up getting hotter than others over the time that you're using an ambient sensing control. So, but there are other ways of doing that with ambient sensing also. And then the last application is commercial, which is our snow melting, gutter de-icing, hot water maintenance. That's kind of the three different categories that heat tracing falls into. So what is electric heat tracing exactly? electric heat tracing is the use of cables to maintain temperatures of non-flowing fluids by replacing them through the loss of thermal insulation, pipes, and vessels. Sorry, that screen keeps jumping on me, but basically what happens is if we do not heat trace a pipe, and we just insulate it, then over time, there's going to be some heat loss, and that over time the temperature is going to seek some level that's less than what your desire is. So in order to maintain that temperature, we put back that heat loss with some type of heat tracing cable. Could be single pass, could be 2 passes, could be self-reg MI, whatever it may be. And so over time, now we can maintain that specific temperature. And of course, that comes out of our basic thermodynamics heat loss equation, which has been around for years, which is heat loss is the area times temperature difference divided by the thermal resistance. In this case, it's the pipe size and the difference between the fluid temperature and ambient temperature divided by the insulation types and thickness. And those calculations, as most of you know, come out of our Chromatrace software. So it makes it easy for you to get those heat loss calculations. It used to be we did that with these curves, and you guys have been around for a while, know what I'm talking about. You had to do all this little math equations to get to these heat losses, but now that's all done automatically for us. So let's look at troubleshooting heat tracing. I like to break it into 4 different categories, and that is insulation, the heat tracing cable and components, electrical power distribution, and then process considerations. So if we look at a typical heat tracing installation without insulation on it, you can see that we have valves wrapped accordingly. We've got cable where we have flanges, extra cable for heat sinks where we have flanges. We have cable that goes around bypasses. So this is what it looks like when it's uninsulated. And so, what we want to do is make sure that we have the appropriate cable in the appropriate places. Now, when it's insulated, we don't necessarily know that it's there, but it's one of the things that even if someone's doing some work and going back and doing some repairs, that we want to make sure that they're putting that stuff back on properly. When we're doing a troubleshooting, I like to start with the heat tracing isometric if the client has heat tracing isometrics. Why? Because number one, it gives us all the data we need about the circuit, right? How much current are we drawing? What's the length of the cable? Where does the circuit start and stop? Okay, if I don't have a heat trace isometric and I'm trying to go out there and troubleshoot the circuit, especially if the end seals are underneath the insulation, then I have no idea of where the circuit starts and stops. So I strongly advise you to make sure that even on the smallest of projects that you get a heat tracing isometric design done, because in this case, if you want to go back and troubleshoot, it makes it a lot easier for us to go back and try to figure out what's going on and where the circuit starts and stops. So when we're troubleshooting insulation, like I said, we always want to start with an isometric. We want to walk down the line and we want to note any missing or damaged insulation, and repair any of those damages if it is there. We want to note, are there insulation blankets? Are they properly installed? Are there missing insulation blankets? Does the circuit have the proper type and thickness and insulation? So we can get that information also from the heat trace isometric if we have it. We know the type and thickness if we just go back to that isometric and look at it. And then caulk and reseal around components. So if we look at a new installation, this is what it looks like, right? It's nice and clean. There's no indentions on the insulation. You can see there's caulking around the end seals. There's caulking around this little ambient sensing or line sensing thermostat that we have installed here. All these insulations are clean, but when we go back and look at a typical job, this is what it looks like, right? The corners of this insulation have been hit, they've been damaged. You can see if you look in the top right-hand side there of the gentleman standing there, you'll also see that looks like an insulation blanket is missing. And the other thing that's interesting about this photo too is that, to me, that looks like that's a steam hose that the gentleman has, that he's taking steam and he's trying to shoot it up underneath the insulation. and he's trying to steam out a line that may be frozen. That may or may not be the case, but it sure that's what it looks like in this case. So again, here we see this insulation is busted up pretty bad. And then in the picture you see over here, there's a blanket that's missing. So all of these areas, the insulation is just as important as the heat tracing, because if I can't keep the heat loss from escaping, I'm not going to be able to maintain the temperature that I want to maintain. You look at this little pipe support here, it was cut out, but it was not properly put back and sealed. So any place like in this picture, or even on these photos here, where there's going to be an ingress of water, now my insulation is going to get cold, it's going to get wet, and I'm going to run the possibility of that's going to be the cold spot that we're looking for. So insulation is a big part of troubleshooting. And on a lot of jobs that I've gone and looked at, most of the time when they say they can't maintain something, I've walked out to a job, the insulation blankets are laying over there, or they've done some work to some valves and they've left the blankets off, or they haven't gone back and heat traced, as in the case of what you see here. Someone just wrapped some piping and just decided, oh, we'll just use it like that. We don't need the insulation, but we do need the insulation. I kind of liken that to someone telling me, well, why do I need to insulate it? And I always say, okay, well, in the middle of the winter, if it's 20 degrees outside and you heat your house up, if you take the roof off, do you think you're going to be able to keep it at 70, 75 degrees? No, you're not, because you're going to lose all that heat, and you're going to lose a good bit of your insulation also. So keep in mind, insulation is a big part of what we're trying to look at whenever we're looking at troubleshooting some heat tracing. Now we're looking at the heat tracing cables and component itself. Same thing. We're going to start with an isometric, right? In this case, we can go look and see if the circuit is drawing the current it's supposed to be drawing. You know, if you have lighted in seals, you can go see if the lighted in seals are actually lit up. Do I have power all the way and continuity all the way through my circuit? Sometimes this data, when I say the data, the current itself comes on electronic controller. So you can compare that with an electronic controller. If you don't have that, then you're going to have to get some kind of electric meter where you can figure out how much current the system's actually drawing. Is the system coming up to the design temperature, maintenance temperature that it's set for? Is the RTD mounted and wired correctly? I see this a lot too. I see RTDs that have been, pipes been repaired, it's been taken care of, and then an RTD is hanging out in the open, or it's real close to some blanket that's missing, or some insulation that's been repaired. And so now we're getting the wrong temperature sent back to the controller, and maybe the heat tracing's staying on all the time, or it's not operating properly. So RTD mounting is a big issue that you'll see. Is the controls operating properly? One of the things you can do is force the heat tracing on. So some panels have the ability to do that. If you have a freeze protection panel, you can switch that to the hand mode. So just keep in mind too that some heat trace controllers have an auto cycle program. So if the client wants to auto cycle the program during the summertime and understand that the system's working properly, that's another thing to help them troubleshoot some heat tracing. Steam hose is used for thaw out. That's one of the things I just talked about. If you take a steam hose and they shoot it underneath the insulation, there's a chance they could damage the cable depending upon the cable that's underneath there, right? We don't know whether it's designed for the amount of steam that's being shot underneath that insulation. So keep that in mind. You might ask, have you done some steam out lately? Do you do it? You know, because a lot of times cables will get damaged whenever we steam out. We look at basic electrical, and this is what we talk about power distribution. Again, we want to try to measure the heat tracing cable, make sure it megs properly. We want to check for the proper operating current levels. Ground faults, we're going to look for ground faults. Is there water in the power boxes? Or is there a cut or a screw or a nick that's in the heat tracing cable? So one of the theories I've always used about repairing things, even in my own things that I like to repair, is I go back and look at what's the last thing I did. If something's broken or something's not functioning properly, it may be the last section of piping that we worked on. We replaced a valve, We changed some piping here. We redid some insulation. So that's a good place to start. And then also you can test the power and RTD wiring. A lot of times I've seen this in numerous applications where you walk up and the power box is broken. Someone hit the power box, it's broken off of the stand. The wire might be damaged, or the cable's been pulled out of the terminations inside of that power box. Or again, we'll see an RTD, that's an ambient sense, an RTD, that's mounted in the shade, right? So we want to look at those kind of issues and make sure that they're mounted properly, and that if it's in the shade, it doesn't need to be in the shade, it needs to be in the sun. And then we talked about process considerations. So a lot of times we run into different people at facilities that don't fully understand what their process are. And so, do I have a full understanding of how the process operates? Because one of the basics of heat tracing is that I can only maintain these temperatures in non-flowing conditions. And so, do I understand when the product is flowing and when is it not flowing? Some people get confused by that. They say, well, my heat tracing is not coming up to speed, up to temperature on this line, but it's working over here. And so a lot of times I'll ask, well, is the process working at this point in time? And they'll say, yeah, it's flowing. Well, we're not going to be able to get to the temperature when we're in a flowing condition like that. And also, is the system attempting to maintain heat from vapors or gases, or trying to minimize condensation? So when we get into those applications, because we have a lot of gases or vapors that may be moving, we're trying to take care of condensation, typically that's on the surface of the vessels. And so even though we have some extreme temperatures on there, we are getting rid of that, but the system may not be coming up to temperature because there's a lot of gases or vapors that are flowing through that vessel. So keep that in mind also when you talk about process considerations. So it's important to understand how the process works. Go talk to the process engineers to get an understanding of what they have going on, and then we might be able to solve some issues there. Everyone pretty much knows what an installation looks like. I showed you some pictures up otherwise, but this is our quick install guide. As I said, it's always great to have an ISO because we know where the power box starts, where it stops, and where our end seals are. If you don't have those, then you're relying on Bubba. And if Bubba leaves the plant, as most people know, we don't know if someone says, well, where does that circuit start and stop? Well, go ask Bubba. He knows where that's at. But if Bubba leaves and we don't have this information, then the next person down the road has to try to figure this stuff out. So it's important, as I said, to try to get those heat trace isometrics and have a whole library of those that you can pull from to go to, because it's going to make life a lot easier for you. Most of you know we do have Chromolux Field Service. It's fully staffed service department. So we can do heat tracing audits if someone wants a full heat tracing audit. We do project startups. We can come in and do this troubleshooting, and we can also provide some programming for you. So keep that in mind as we get into this winter season where people start to look at their systems. And then the last thing is heat tracing design information, right? What do we need up front as a company when we're looking to do a design for a heat tracing system? So we need specifications for the heat tracing, electrical, and insulation. We talked about insulation. A lot of times people forget about that insulation, but it's a key component of a heat tracing system. So we want to know what type of insulation, what thicknesses we can get by with. P&IDs, that goes back to the flow, understanding flow and non-flow conditions. That's how we're going to circuit some of our process maintain applications based upon those P&IDs. Piping isometrics, area classifications, what's my minimum ambient, maximum ambient, the maximum cable exposure. That goes back again to people steaming out lines and damaging the conductive core of our self-regulating cable. So we want to make sure we understand that. What's our maintain temperature? We want to get those insulation types and thicknesses. And am I doing a freeze protection or a process maintain, right? Need to understand that. And then degradation temperatures of specific products. So when we are doing some process maintain applications, there are certain chemicals in certain products that have an upper temperature limit where we start changing the color or we change the composition of that product if we put too much heat into it. So if we do have an application like that, we want to ask, I always ask that question, because you don't want that to come up after you've done a design, after you have something installed and you've got everything sitting there and the client says, well, you're overheating my product. So keep that in mind whenever we're doing, especially a process maintain application. Other than that, I think that pretty much covers it. Like I said, I think it's important that you understand those 4 different categories and have an awareness of them. It'll help you figure out some simple things. We're not diving into a lot of technical details on how do you go about megging a cable or metering or doing stuff like that. You know, we'll leave that to the electrician, but just kind of gives you an overview of what you really want to look for when you start to have issues with heat tracing.